In this lesson, we will look at solutions that are made from different solute-solvent combinations and distinguish between saturated and unsaturated solutions. We've primarily looked at solutions where water is the solvent. However, solutions exist in all phases. For example, the air around us, the solute is a gas and the solvent is a gas. In steel, the solute is a solid and the solvent is a solid. In a mercury filling, the solute is a liquid and the solvent is a solid. In soda or carbonated drinks, the solute is a gas and the solvent is a liquid. And in a substance such as isopropyl alcohol, the solute is a liquid and the solvent is a liquid. One thing we need to consider when we're looking at a solution is whether or not it is saturated or an unsaturated solution. Before we see how this applies to solutions, let's think about a sponge soaked in water. On the left, we have a sponge that has some water in it. However, we would consider it unsaturated. And this is because additional water can be absorbed into the sponge. So if I poured water on the sponge, it could absorb it. There is a limit to that, and at some point we get to a sponge that is saturated, that if I pour more water on it, it would not be absorbed into the sponge. It has absorbed the maximum amount of water. Even if I continued adding more water, it would run off, but we would still consider that it is saturated because it has absorbed the most water that it can and additional water is not absorbed. We can apply the same terminology to solutions. If I have a solution and I add my solute to it and it dissolves, what that tells me is that my solution is unsaturated because additional solute can dissolve. However, if I add more solute and it does not dissolve, as evidenced by the presence of the solid in the bottom of the beaker, I would say this solution is saturated because no more solute will dissolve. The solution on the left, therefore, is unsaturated, and the solution on the right is saturated.